right, here we go. We're going to go ahead and look at concept 13 all in one big video. So hopefully you'll get all that you need here. First of all, it says expand each expression. I'm also allowed to reduce first and simplify this a little bit here. So if I wanted to do that, this x makes this into just a squared. So I end up with just log of y to the 8th over x squared. The division is subtraction. So that's going to take care of that. The 8th, the power, remember, goes out in front. So the division is my subtraction, and then my power of my 2 goes out in front, and I'm left with just an x. And so that is expanding that expression. This one here, there's a lot of options that you have. We've been encouraging you guys to kind of go as far as you can with it. So if you look at 75, it's really what, 25 times 3. 25 is really 5 squared. So if you saw it as log of 5 squared times 3, you would bring the 2 out in front. And then multiply is really plus. And you would leave it like that. So that would be the most expanded and simplified. If you wrote log of 5 plus log of 5, yeah, that's okay, but it's better to put them together, kind of like we see going on here. So let's go ahead and go straight down to here and take care of this action here. The 4 and the 3 are really exponents. So just like these change into 2, if I'm going backwards, it's going to be just one log here. So this one would be x to the 4th, subtract means divide, and this would be y cubed. We're going to do exactly the same here, but when we are done, so the 3 ends up being up on top there, the 2 ends up being up on top there. Remember, subtract means divide. You end up getting log of 64 over 4. Which really is log of 16. So the only difference here versus here is this one here, you can actually do your division, like you can simplify it. You always want to simplify things if you can. Over here we didn't because we couldn't simplify. You have x's and y's, and so they all need to stay the same. So back up here, again, simplifying is definitely a good thing. All right, so we're going to go ahead and now look at our approximate values. And for each of these, really we need to change each of these numbers into a bunch of 3's and 2's. So this one here, 12 is what, 4 times 3, which is really what, 2 squared. So that's why we learned how to do all of this fun stuff here. So if this is 2 squared, that's 2 log 2 plus log of 3. Remember, times means multiply. So, and again, 2 log 2 is really 2 squared, which was the 4. What does that mean? I need to add 2 of those with 1 of those. And so I did this earlier, and I got 1.54. And you want to just check and see, does that make sense? So 5 to the a little bit more than 1 would be true, because 5 to the first would be 5. 5 squared is 25. It's a little bit like in between there. So that would be a reasonable answer that we would get. For this one here, this would be what, 9 times 4, which is 3, 3, 2, 2. So I have 2 of the log 3's, and I have 2 of the log 2's. So I want to add 2 of the 6/8, and I want to add 2 of the 4 3's. Again, I did this one earlier, and I got 2.22. Again, 5 squared is 25, so it's reasonable that it would be a little bit more than 5 squared. Last but not least, we have the 3 and then the 2. So remember, log of 3 would be the top. The divide means divide means subtract. So I want to subtract 2 of the log 2's. So I'm going to take my log 3, which is 0.68, and subtract 2 of the log 2's, which is 0.43. Which ends up getting me negative 0.18 as my answer. Does that make sense? A negative is going to flip it upside down, and then a decimal is definitely going to make it a little bit smaller. So that would seem to make sense that I would get this nice little small 3/4 if I were to do all of that fun stuff with it. All right, sounds good.